Okay, so where we left off, where where we were at converge. Someone said me uh, they did not understand the curry. Curry, as in how the curry
Work.
works, or where to how to use it. Oh, the application of curry, right? Okay, so this is one of the application of currying, right? Yeah. Okay. Okay.
You
If
already wrote
okay, I'll.
sum of to a comma.
Is it visible? Okay. So I have something called as add, right? What it does, it takes simple two numbers and returns the, right? I can say one or two, right? But that is fine. Uh, but what if my requirement is always add to 10? Then how do I make use of this add function, right? So it is where the curry comes into a picture,
Because I don't tell me
right? So JavaScript in, sorry, hello, is it sensing my heartbeat? Okay, so uh, just a minute. Okay, so I like to add, but I like to, so here the way I would do here is essentially uh, a, but that wouldn't be anyway, b. A is already present, which is in terms of 10. This is the effect which will you get after doing the curry. Okay, so to 10, right? So this is simplest example. So basically, any function which you have created and which takes more than one argument or even one argument currying is hard to imagine, but more than one argument, and some of those arguments are already fixed. Okay, curry always, the curry concept itself always consider from left to right. Whatever you want to have it as a default, you mention as a left. I mean, you start with those variable, and the right variables are which going to be there when the actual application of that curried function happens. But in case of Ramda, you get flexibility of putting every other currying in any kind of any argument at any order. That's what we did here by placing the curry placeholder.
so the same add function can be carried, right?
Yeah. So another, I mean, it could be any other. I like to book a ticket for a movie called Arrival. Okay, so there is a function which takes movie and the time. Okay, but in my case, time is not fixed. But I'm sure that I like to book a ticket for Arrival. Okay, so you put Arrival, you return the curried function, right? And you apply to asking different person what time would suitable for you. So that's the time. Say if you're using Ramda, you could do other way also. Even if the movie name is the first argument, you can put a placeholder just like we did for module operator. I like to see any movie at this time. Okay, so what are the movies available? Okay, you choose it and you apply it.
So it will be something like if I am on the page of movie selection, so I have clicked a particular movie, then it will create this. I am just nothing to do things. So it will create a function from selected movie and it will start to be on to this particular movie plan related to another page.
Yes, yes,
So it will pass that function to the other page and it will be executed there. It is
yes,
something like that.
yes, yes,
Something like decorative.
yes, correct. Yep, yep. Now since you mentioned it, your first question was about the application of it. That is why I explained that if you like to, I think I had this back in the day. Where is it? Where is the curry? I want curry. This is function binding. This is curry. Is it visible? SlideShare people. So when I first uploaded this PPT, it didn't have curry, and then I later uploaded. But when I switched to the full skip mode, it doesn't have that slide because it's still pointing to the old one. This is replication gone bad. Okay, so what this curry does is it just saves the argument from the previous function, and then when you actually call it, then applies to the actual function which you passed. Okay. Okay. So this is also curry, right? Because the original number of arguments map needs is 2, but we are only passing 1. The filter needs 2. We are only passing 1. So instead of passing the actual value, or instead of having the error, it it just automatically or auto intelligently inspects that, yeah, user want the curry to happen. So it returns the curried function, which when get called by that will result into the actual value, as if the whole map is applied to that. Okay. And we see the converge, and so, but the main thing, I mean, there are many functions and all things, but my main motto of conducting session is for you to understand how we are step by step building the abstraction, computational abstraction, right? And these are nothing but just internally adding it, some, filtering it, mapping it, some kind of operations. And as we grow together, different functions, how we can make them more common and have a different function, which is actually the composition of other simple functions. Okay, now this is an example of lazy range. Yeah, so this thing is not lazy, right? We talked about lazy, right? Lazy evaluation for functional programming, because we don't want to fetch unless we are doing a computation on it, right? As simple as that. But this thing works on the actual thing, the actual arrays which are there in your heap, runtime heap, RAM memory. Uh, so how to So there are various ways in JavaScript. The way you do it using only simple generators is this. Right? We also have seen this the same example here. Range generator. There was a range generator, right? Yeah, the range. It's the same thing. With recursion. Okay. And this is map lazy. Why map? Suppose you are doing this function, this mapper function is very expensive, either in space or either in whatever it is. Okay, so I want to do it lazily, or the data which I'm fetching uh, is like heavy. It might be in MBs, not in KBs. So I don't want to, produce unnecessary. Uh, I don't want to increase my heap size and trigger garbage collection and so on and so forth. So what I do is I iterate over it and simple function apply it. Basically, this is the actual, by the way, implementation of a map function. Okay. The same thing could be for filter. This is, and this is why it is called as higher order function. Is like you are abstracting away, which is the dynamic part of it. You abstract it away into the function, right? But here you are also making it using the generators. So if you observe carefully, it is a generator. I am making a self-reference call so that I get a range that generator object itself. Okay, just calling a generator doesn't start it. You have to do it explicitly. But just to get to the instance of a generator, I have a self-reference call. And that is the return value of that map lazy function. Okay, so I can compose them, right? Take a range lazy and compose with the map lazy. The output from the range lazy act as an input to map lazy. So so instead of range lazy, you could read from file stream, right? If you are doing some CSV processing, read row by row, right? Then pass it to map function. Then you are building the whole pipeline here. Okay, and then you have filter lazy. So let's try to print the output first to the. Oh, sorry. So what is it? You have a range which is mapped to a square. So it's like square for all the numbers from 1 to 10. Okay? Right? Once you do map, you can also do a filter. And in case of filter, you will only yield if it returns a Boolean value. Right? All the odd numbers, all the unique numbers. And this is again a destructuring thing, right? Destructuring thing which we have seen here, right? Just like a foo bar, we call the generator and it's spread over the array and creates the array, right? Now you can do other compositions also. Range, filter, map, right? So if I comment it out and So noisy. Yeah. So what do I get? You first filter it, only consider the odd numbers, and then you make a square. Okay? But in this case, when the map function executes, it calls to the whole level, go to that next, right? Go to the filters next. Then filter before the next of this filter happens, go to the lazy range next. Then once you receive the value, then you receive the value one by one. It's all lazy, right? So this will help you get away with some space issues and while doing the computation and also building the pipelines of functions. Okay, any questions here? Okay, just have a look at it. Yeah, it will be. I'll share the link for that GitHub and as well as the PPT on the meetup page. Okay. Okay, so that is how we do the lazy computation using the generators, ES6 generators. You can also do some lazy. Now some, because it only produces a simple value, it doesn't have to be a generator. It could be a generator if you like to proceed that value even to a next generator, but normal sense it's a reduce operation, right? So you can, so this is the 165 of all the sum of the square of the, yeah, so this is readable, right? Sum of the square of the all the odd numbers between 1 to 10. See? By just simply composing it. Okay, and what we have done here, simple thing again. You could use you could use here the for of loop, or but if you use for of loop, then you have to maintain one and make the mutation. So I'm using here the recursion. So once you have only immutability and only pipeline, it's very easy to, reason about the program because there won't be any other value unless time is the one of the variables which is taking into consideration for that equation. Okay, so that about some lazy. Right. So the same thing you can do with Ramda. They are called as transducers. Okay, so what are transducers? It takes the transducer function. It is again very similar, but we have to like compose of map and filter. Okay, curried thing. These are just a computational abstraction. It doesn't have to do with data, right? It's a computational abstraction. And then you have a reducer function for sum and the initial value. And look at this. Unfold, you will be using unfold to have a lazy iteration. one simple function, one simple higher order function to create that. And what does it takes? It's a function which takes a predicate. It's a hybrid actually, not a predicate. It's a hybrid of a transform function and a predicate. If it receives the false value, it just stops producing more. Okay, that was the case with the recursion also, right? When we are doing this thing, okay. So what does it accept? Num value. It checks if it is greater than or equal to 10, then stop. Otherwise, send the current value and the next value, and this next value would be used to call the same function again to produce the next value. Current and next, current and next, current and next. Right? So this is very much like a generator where we were doing like value done, done, done. It's all false and then it becomes a true. Here it's like reverse, like false, then you stop. And you focus on the, until it is false, you focus on the values, like that. So this is like unfold a simple thing into a lazy iteration. So it will not consume memory or it will not create the whole array. It will only compute as you go. Right? Now once you have it, okay, so this function is getting called and then you have a transduce function, right? And you have the OR function, filter. So output of this is fed to this. Once it is there, then you apply reduce on it with the initial value as 0, and then you produce the output. That was 165. It is very similar to what we have here in some lazy, right? Some lazy output was same, right? Okay. And all of these are mentioned in here with the, I mean, the documentation is really great. If you can expand the parameters, you could see that seed value, the iterator function, next call, right? Okay. So that about transducers. Now transducers, because of their characteristics and all, they are also used in other languages for parallel processing. Okay. So like Clojure, for example, have inbuilt reducers. Many other languages also have it. And because you are doing immutability, the whole data structure is immutable, and also the side effects you are creating in your database or any other system is also associative. Like order does not matter, right? When the particular operation happens, if order does not matters, you straight away parallelize that. Okay. Now, yeah, this is so. Okay. Mm, Maybe we can have this. basic operations and emit pairs, lenses. Okay, let's start with so so the object category. We seen much of the iterable category like list and all, and there are so many things which you can try from. If you look at the list here, any and for each and flatten and reject. Reject is opposite of filter. Tail, head, tail, transduce, transpose. There are many of the things depending upon. Okay, so as a job, as a in the daily routine, as a function programmer, the more I know functions which are readily available, more productive I'll be. Because I don't have to otherwise compose the primitive ones. Okay, so how do you do the simple things here on the object? We have seen on the list how do you do simple things on the object here. Now, what you could do with the object is get all the keys, get all the values, maybe add it, maybe take something out of it, okay, and maybe check for some possibility that certain attribute present or not. Okay, but if you do it JavaScript way, there are like object is the main function or main class or something like in JavaScript where all descend from, just like in Java. Okay, so they have like object dot keys and object dot values, but and their whole thing like even map filter are there, but you have to call on the object. They are some of them are mutable, some of them are not. So it is good to follow only one library, which are in which all the things are immutable. That is why I said you can use RamdaJS as to replace the standard collection library or the object library of the JavaScript SDK. Okay, so how do I do it? So keys, get all the keys for the object, get all the values. Whenever you want to add it, okay, do using assoc. Associate this attribute with this value to this object. Deassociate this attribute. When you say deassociate attribute, is like the whole pair you are deassociating, not only the key. Okay, the key value pair, and from this object. You should not use delete operator in the JavaScript. You use delete operator like delete, and then it causes the thing. So all of this create a new this thing. Okay, because if it does not create, so let's run this. And this thing, right? So keys are, these are the keys, nationality, profession, name, and married, and these are the values, right? Add attribute. When I say add attribute, height, it doesn't add the attribute in the actual object, because if it did, the output of these two, remove and shake, should include the height, but it's not the case here. If you look at the output, it always produces the new. It always, so there is always transformation. There is no manipulation. Okay, and this is very decent. So and for this reason, I can pass obj object to any other method, and if you are following immutability all elsewhere, I can rely even after I pass this value to any function. After the function application happens, I could assume that this object going to have only these 4 pairs, not one less, not one more.
How does it clone the object? Because JavaScript is not
But clone
How does it?
clone the
How does it close the object? Yeah, it's going to be deep clone. I mean, functionally, it's going to be deep clone, of course. Yeah.
open
So internally, it uses mutability.
open your brain.
Yeah, there is one more thing, like, so this mutability is inside the function scope.
So it will
You are not passing anywhere
it's
else.
not actually we can say it's pure only, right?
Yeah.
So you are not
Exactly.
Right.
A pure function which maybe use transient data structures. Transient data structures are which can be manipulated, but they do not pass to the any other function. So we started from very perfect world of immutability, and we are seeing that where side effects could be helpful, but with a very constrained limits. Okay, and this up. But you don't have to worry about it. I mean, what you don't have to. I mean, what you only worry about the code you write and see and read, and you have to maintain, right? Not the has is just like check whether it has it or not.
So, so when we associate or dissociate, the object remains the same in this it's muted.
Yeah.
So when we print the keys and values again, it will only show us for attributes.
You mean after this?
Yeah.
Yeah. It should show the same. Okay. Uh, hmm. And based upon these things, there are many functions in Ramla. Just for object, right? ASOC, ASOC path is if you have a complex object. So you can see A, B, inside A, B, C. What is the value of it? Just like that. Okay. We'll see that when we see lenses. Okay, so these are the things, and just for fun, I have exercise for you guys to be performed here. So this is the input, this is the output, and you tell me the transfer function. And we can look at all the object methods which are available here. We have to find, we need to find something. Do you understand the input and output? What is the change? The keys are prepended and appended with hyphen, right? And the same object we have to, so input and output using Lambda functions, right? So what functions we should make use of? How do you, first of all, how do you think it's going to happen? It's more about thinking, not even data functions, it's more about thinking. How do you do a transformation?
Create the new object with new key. And then
Or maybe I can solve this one for you, and maybe the second one you can solve it for me. Okay. So the way I would think here is destructure the whole object into keys and values, transform the keys, and bind the object again.
create the new object.
Destructure it, transform it, bind it again. Right? So we have here two pairs. Okay, so what two pairs does? It converts the object into pairs. What are pairs? Pairs is nothing but an array of fixed size 2. First is always a key, transform key. Second is always a value. This is two pairs. This is like destructuring, and what you have is to bind it again from pairs. Bind it again, and in between you do the transformation. Right? So how would you do it? So maybe first calculate this. This we can have it like if you want. Like I need a pairs. So two pairs, right? Pairs of what? Input. Okay. So the we received pairs as what? First name Charles, last name Bukowski. Right? Okay, now I have to, so this is original pairs. I have to transform it. How would you transform it? And what would you transform it? Huh? Transform pairs. Transform pairs will have what? A map function. You pairs would be the input to it. And what would be the function? What would be the function? Function would be, I am receiving an array. I am only interested in key. Sorry, both the values and key. But what I return is dash and value. Value remains the same, right? Okay. So what are the transform pairs here? Sorry. Okay. And the stuff which remain here is what? From pairs. From pairs, transform pairs. Okay, so when you transform it, transform would be the actual output. Right? So what do you see here? If I remove the console log statement. What do you see here? Can I just define it as something constant? Transform is a function, is a transform pair. Replace this with the actual one. Okay, where is my cursor? Okay, and replace the pairs with the actual implementation, right? Get away, get rid of this, get rid of return, right? From pairs map to pairs. Right? Okay, let's run it. Yep, the same. Now, can you define this thing into a Ramda? I will leave that as an exercise. Only the Ramda functions. You will not define function here, JavaScript function. Okay. Now, okay, the second problem. This is gone. Okay. Now, how to think about it? Let's observe what is the input, what is the output, and transform is going to be a block between input and output, and what should be the transform function. Can you make a difference between input and output? What has changed? Two properties are not there, and only which have the value, which are the numbers. Okay. So again, destructure, filter, and structure. Yes. Okay. So how do we go about that? Same pairs. Okay. Now two pairs. Yeah, right. Then what? Okay. Filtered pairs. Filtered pairs as what? What would you like to define? Why would you take a key? Hmm? Hmm? What? This is something you are supposed to solve. I'm not. Why can't we? Sorry? We can deassociate, but the problem statement here is to just a number value. If you only look at the input and output, of course you will apply the deassociate first name and deassociate last name, and job done. Yeah, but the thing which I'm trying to solve is we need to omit the pairs which do not have a value, number value. So we restructured it. Then what? The first step and last step we know. Yeah, so key and value and is number, right? Key value is number so what I would say here is sorry, it is a number. What is a number? A value is a number. Okay, then we get a filtered pairs. Then what do we do with the filter pairs? Return from pairs, filter pairs. And that's it, right? Should work. Right? And again, you can do the similar thing here, like from the composition and all, same thing. Okay, so that's about that. But are you getting the main intention is like transformation of data? How do you do at list level? How do you do at object level? Okay. Now there are some really nice functions like evolve. This is my favorite function. I use it quite frequently, and it's really useful. What it does is many times you have some really crap objects, some especially when you work in schema-less domain where or even in the IoT like environment where something is producing value but it's in a string format. What you wanted is the integer format, vice versa, and many other things, right? You get that object and you want to transform it, and that object is not a plain object, it's a composite objects, right? And you don't want to do that operation, a single thing. There are different unique operations on, could be on some of the attributes or all of the attributes. So this is the way to do it. Okay, so my initial object is tomato, whose first name is also tomato, and data is elapsed, whatever it is, whatever crap it is, okay? And I like to first trim the first name, trim the last name, okay? If it is not there, it will not get invoked. I don't want error, right? Just and so data is a composite object, right? So data itself is an object, elapsed, whatever is the value, add 1 to it. Whatever is the value of remaining, subtracted. So this is where again curry is useful. Everything everywhere is curry actually, but yeah. The same example we have seen, like add to 10 is like add to 1 and subtract 1. Okay, and then when you evolve, so evolve tomato into another transformation, you will get such values. Right? So it's trimmed, the first name is trimmed once, last name did not exist in the original input, so it didn't care, no errors. The elapse is incremented by 1 now, and the remaining is decremented by 1. ID is same as it is. Okay? So many times you will use evolve with map function. Because map receives the particular object and you are sure that either you're adding or doing something or something. So that's there. Now lenses are as they say, the lenses. You know, you have an object data structure and you send lens through it. In computational sense, the lenses are how do you navigate through the properties and get the values of it. Okay, so lenses accepts a getter value and a setter value. So this is the getter value, property X. Okay, get me the, so lens is saying that get me the, this is the getter and this is the setter. ASOC is a setter, right? ASOC we have seen here. Where we have seen it? Here. Setter. Okay, so there are different functions like view, set, over, where you can pass the lens. Okay, so this is my view of the world, and if you want to view it, so this is only view it. Okay, get the X. Lens, I like to view the X. So okay, view it. I like to set, okay, set the X to 4, value 4. And this is the actual object. So internally, it says ASOC X4 on this value. Okay, because here it is, so here it is using getter, here is using only setter, getter and setter both actually. And over, now observe this. You have passed the getter and setter through X lens. You have a negate function. Now you are not passing the actual value to it. You are passing the function. Okay, which will be applied for that value of that attribute which you are passing. Okay, and this could be different. If X is this and then you set the Y. Could be like that way. So it will return the same thing like X minus 1 and all. If you are dealing with arrays, you have 0 and 1s, lens index. Right? Lens index, you get a lens, get the head, set the head to X. Okay? And if you use over, make a uppercase of it. Or use both of them in combination, lens path. So X, the value of X is actually an array, pick a 0th value out of it, and then you set the Y value to either 1 or make a negation out of it. Right? And these are really useful if you are dealing with composite structures, lenses. You define, and you see the reusability. We not even have made reusable the computation, but also the lookup. Lens is just a lookup, right? Lookup is also reusable in terms of functions. Okay. You can you apply now lens index to this? Because this was a lens index, right? Here. Lens index, if you apply 1 here, what you get is the value. right? And then you apply to each number. Make sense? No. So what you do here is you compose, right? Is less. So value will come from this thing. The first thing is to have length index. Length index of what? 1. And if you, wow, it's gone. What went wrong? We have applied the length index of 0 to view set and oh, is it has to be used along with this? Might be. Uh, there is also a property. Okay, lens prop x. It has to be used with the view. Lens index and view. Yeah, that's what we say. Yeah. Right? Okay, so those were the lenses. So lens path, lens properties. And so what we all have seen is data transformation, right? But if you like to do some domain, I mean, as we have seen, like we have value, we have data, right? We have value, we do not have state, like it's just a temporary state. We also have a time, but we do not have a logical entity called as identity, which is from domain angle, right? So from domain angle, what do you do is, so this is the set which I have. These are the tasks for Amar, Priyanka, and Pawan. Some of the tasks, some tasks, and due date and priority, some data. Okay, and I am making a DSL out of it, simplest possible DSL. Okay, so what do I have here? I say what are the incomplete tasks? What is incomplete? First, incomplete is filter. So these are all our higher order functions, curried functions, or call them transducer if you will. Okay. So what they are incomplete. Get me all of the things from the collection which has a complete as a false. Complete is true. Right? So incomplete tasks. Task is what? Task is the actual collection here, the records. Okay, when I say Intel is tasks. So these are the tasks. Okay, these are all, sorry, what are incomplete tasks? If you look at them, all of them have complete as a false, right? And it is an array. right? Okay, I like to see completed tasks sort by date and group by user. Group by use, group by user, all of the sorted by date, the completed tasks, right? So what is complete? Complete we have seen. Sort by date is what? Sort by property due date. Okay, and then you group by user. There is already a group by in Ramda by property username. And you see it. Completed task. So, so this is the object. This is the key. Priyanka and Amar. Priyanka completed 2 tasks. Amar completed 1 task, and the third person did not complete any task. It is Pawan. Yeah. Okay. So this is how you domain specific thing. Okay. That is how you build abstraction over and over, composing it again. Active task. What do you mean by active tasks? Which are not completed yet. Okay, so active by user is what? Incompleted tasks which are grouped by the user. Okay, so those are active by. So these many things, these many tasks. Priyanka has still a lot to do. Amar has still a lot to do. Pawan has only 2. Things like that. And all of them have complete false. And this is like top data. It's nothing but doing some sort by over it, okay, and just picking up the important fields out of it. Project is, so you have, if you have some list or something, sorry, the object, you project this title, due date, project those things, as in the SQL projection, what you do in select statement, yeah. This is the top data, the title. I only need a title and a due date. So these are the tasks which are right. And one more thing is, so because there is no notion of state, there is no data. There are only, even if you're building a DSL and all, there are only the transformation functions, right? Now, if each and every time you have to execute that, that could be the hit on performance. So for that, you use something like memoirs, because as much as you are making the pure functions, memoirs function will let you cache the results. Okay, so here you have a memoirs. Memoirs is like, suppose certain function is very computationally complex. It takes like 1 second, and it has been called like 10 times for those 10 values. So if you use memoirs, it internally maintains the hash map, essentially the object, and it checks if it is called already by this function and returns that cached value. Okay. So that is how you build the DSL. Okay, just have a look at it. I think you are pretty okay. How about the DSL? Any question on DSL? These are just compositions. This is the last thing. I wouldn't overload you with any other thing. This is the last. I wanted to have the another using the generators and all, but I didn't actually get time to do that. Where actually you fetch the data from the services and all. But I think for today it's sufficient. Maybe some other day. Yeah, and one quickly like to go through, like we have seen like compositions and all, but in actual sense, actual real world at Red Panda, we have done this, like implemented a library for the data validation, which also based upon the same things, like these are simple functions and you can make use of that. So if this is the schema, if you're expecting everything is like name and string, you can define your own functions to guide at this. And there is it is open source and it is on GitHub. Yeah, npm also work. So these are usable, like you can have this schema and all of these are functions. Okay, and if you want to do a simple different validator, right, you can also do that by defining a simple function. You return the error message, actual message, or you do not return anything, or if you return, you return the true. So that's like is valid. If it encounters a string, it's like that's treated as an error message string. And this all because of simple functions and composition of functions, higher order functions, and naming them close to the domain which the problem which you are trying to solve. Okay, that's all I have for you today. Thank you for coming. Thank you for listening to me.